So this is a question on chemical equilibrium from 2009. It's a half question. It's in question 11. So answer any two of the parts. There's three parts. In this year, there was part C. Usually part C of question 11 is on the option. In 2021, there will not be the option examined. So question 11 will be A, B, and C, but C won't be on the option material. So half a question, you do any two parts and you make up your full question. So having a look at this question, we're looking at, it's mostly a theory question. You can see here, ammonia is formed by the Haber process according to the following balanced equation. The table shows the percentages of ammonia present at equilibrium under different conditions of temperature T and pressure P, when hydrogen and nitrogen gases were mixed in a ratio of 3:1. Find from the table the conditions of temperature and pressure at which the highest yield of ammonia is obtained. So you just look at the table here, you can see that, and you just find the number that is highest, and you can see that 92 is present there in the 1000 atm pressure and 573 Kelvin temperature. So for 2009, question 11, part A, part 1, it's 1000 atm and 573 Kelvin. That's the answer for 4 marks. On to part 2. Looking at part 2. Deduce from the data whether this reaction is exothermic or endothermic. Explain your answer. Well, you can see here from the table that at, I suppose, exothermic and endothermic, what we're looking at is the temperature then. We're looking at the temperature value. And you can see here that when the temperature is lower, the yield is greater. So you could write that down. A lower temperature results in a higher yield. Of NH3. Okay, and just to make sense of that, what that means is that, okay, there's a higher yield of this at a lower temperature. Now, what I said before is that what you could do to help you understand, to help you figure this one out, if you just drew the equation H2 and N2 gives us NH3, 2 of these and 3 of these. Now, if we were to say that this was exothermic, most reactions are exothermic. An exothermic reaction is one that gives out heat. So heat would be over here with the products. Now, if you were to heat this up, it would move away from the side with the heat because this is the stress applied. So if this was an exothermic reaction and you heated it up, you get a lower yield of ammonia. Now, in this case, we're saying that it moves over here when you cool it down. So it moves forward when you cool it down. So in fact, this is an exothermic reaction because with a lower temperature, you're getting more of the ammonia. So this suggests that the reaction is exothermic. If the reaction was endothermic, you'd be putting the heat here at the front. So again, if you heated it up, it would move forward. So we're suggesting that it's exothermic because when you cool it down, it moves forwards. And you can see that with a lower temperature, you get a higher yield than when you have a higher temperature. On to part 3 then. Part 3 looks at pressure. Identify one industrial problem associated with the use of high pressures for 3 marks. Well, I suppose there'd be a risk of explosion. That would be a problem. You could also say that there's a safety risk. There's probably a greater cost involved because your equipment probably needs to be able to withstand such pressures. So loads of different things. You only need one. Risk of explosion is a good one. On to part 4 then. Part 4 is looking at the equilibrium constant, Kc, for this reaction. So when you're doing the Kc expression, you just put down the products on top in H3 and to the power of whatever number's in front, and you put the reactants below H2 and into to the power of whatever number's in front of them, just like that. And that's the answer for 6 marks. Every year this comes up, 6 marks for it. And the last part, part 5, state the effect on the value of Kc of using a catalyst and justify your answer. So part 5. So we know that a catalyst does not change the position of equilibrium. It just speeds up the rate at which you get to the equilibrium, but it doesn't change the position of equilibrium. And as a result, so it has no effect on the Kc value.